All right, next topic, repeating decimals. So being able to write a repeating decimal as a fraction, it's very repetitive. Sorry for that, but it really is. Like you can essentially do the same thing over and over again. But what we want to do is we want to look at it from the perspective as an infinite geometric series. Okay, so what I want to do is I want to take this guy right here, and what I'm going to say is that anytime you have a repeating decimal that you're trying to prove is a repeating decimal, like not prove that it is, but to prove what its fraction is, its rational version is, what you're going to want to do is you're going to take the part that's not repeating and kind of just chop it off. So you want to think of it as that plus this guy over here. So the repeating part is this part. So we have essentially 0.23, right? So 23 hundredths plus, and then now I'm going to talk about this guy. Well, that means just 44444. So you could think of it as 0.00, and then you can write a bunch of fours, 4, and it doesn't stop. It just keeps going forever. So what we want to do is we want to analyze this guy right here. Like what does that mean? This is straightforward. This is just 23 over 100. So we have 23 hundredths right there. Now this guy is a little bit goofy because this guy we can rewrite as 0.0004 plus another 0.0004. That essentially, if I add those two together, that would give me this guy and this guy. And then if I add another 0.00004, that would give me this guy right here. And this is just going to keep on going forever. So I'm going to keep going forever, and it's continually going to give me another decimal smaller, but with a 4 at the end of it in succession. So how would I rewrite this? So this one I wrote as 0.23, so it's 23 over 100. I can write this guy as 4 over 1,000. So we have 4 over 1,000 plus, and I can write this guy 4 over 10,000, 4 over 10,000, and then we get this guy over here, 4 over 100,000, 4 over 100,000. And at this point, you can look at it and say, well, it looks like it's just a infinite geometric series. So I am going to say that this is my a sub 1, so it's an infinite geometric series where a sub 1 is equal to 4 over 1,000. And then I'm going to say that our r is equal to 1 over 10. And the reason I'm thinking it's 1 over 10 is because I'm multiplying the denominator by essentially 10. So this guy here gets multiplied by 10, it now becomes 10,000. Multiply this by 10, this now becomes 100,000. Multiply by 10, now becomes 1 million. And it's going to keep doing this forever. So what I'm going to do now is, if I'm trying to find the sum of an infinite geometric series, then I now need to be able to add up all of those terms right there. The good news is there isn't a formula for that, and the formula is just a sub 1 over 1 minus r. So I can take my formula and I can plug in a sub 1 and that r, and I can get 4 over 1,000. So 4 over 1,000 divided by 1 minus 1/10. And then just simplify this thing right here. Now me personally, I'd probably do a little bit of fraction reduction here. So I'm going to get rid of these fractions of 1,000. So I'm going to get rid of that 1,000 by multiplying the top and bottom by, yeah, that's right, 1,000. And what this will give me is on the top, it'll turn into 4. So running out of space, so I guess I'll just write it over here. I'll get 4 over, and then on the bottom I'll get 1,000 minus 1,000 minus 1,000 divided by 10 is just 100. So 1,000 minus 100. Now when I subtract 1,000 from 100, what I end up getting is 900. Yeah, 900. So what we end up getting is that this guy is 4 over 900. So we now have 4 over 900 plus, now you can't forget the original part of the 23 hundredths. So we have to add that guy back into the problem, 23 over 100, common denominator. So multiply that by 9 and 9, and that'll give me 180, 27, 207 over 900 plus the 4 over 900, which would now result in 211 divided by, 900. Now, if you don't believe that this equals that, what we can do is we can take out a calculator, and then we can just multiply it. Let's see, what was that again? It was 207, no, sorry, it was 211 over 900, so I'm going to go 211 divided by 900, and we end up getting 23.23444444, kind of like we have right there. I'll send another video so you can see what this looks like from another problem, but this is the basic structure of it.